Not done yet.
How bad are they?
We will talk about it on Thursday.
Oh man,
Did I get a 7?
they're pretty bad.
Alright, it's 11. Okay. It is 11 and 10 seconds. Raise your hand if you don't get a quiz yet. Please take a quiz. Okay. Who else doesn't have a quiz? Everyone have it? Okay. For today, we will talk about the project. After we finish talking about the project, we will talk about homework. Okay, and then we will talk about flow assurance. One for him. All right, the project. Who read this yet? Anyone read this? Question? No question? Really? There should be some question. Okay. This time, I will make the grading very accurate. Okay. What you will do is there are 3 sections. See, section part 1, okay, part 2, part 3, okay, and you will do self-grading section, effort distribution section, okay, and there's checklist. For those of you who don't have quiz yet, just go sit down. I will give it to you later. Appearance, formatting, professional look. That's 10 points. Okay, that's just 10 points. Teamwork part, 10 points. Calculation example, 40 points. Subject matter discussion, 40 points. Okay. Question, yes.
Yeah, can you make the teamwork and formatting 20 points and then take off 10 points on the calculating?
I don't think you guys have good teamwork. Yes. How do I want it? Okay. Black one. Okay, look at this. Calculation example, 40 points. If you do everything, but you miss 4 points. Everything means, okay, there are 16. Okay, number 1 to number 16. Okay. If you miss 1, instead of 100, let's say everything else is perfect. If you miss 1, you get 90. Okay. If you miss 2, you get 80. If you miss 3, you get 70. If you miss 4, you get 60. It is difficult to miss unless you intentionally trying to miss it. Okay. So read it, but basically, whether you have the equipment or not, okay, whether you have the equipment or not, you will show the calculation for each of these. If you don't have the equipment on your field, what you do is you say, let's say you don't have any liquid pipe. You say in this project there is no liquid pipe. Nevertheless, the calculation example is given here as follows, and you come up with your number. Okay. Flow rate is this much, how much is elevation term is this much, how much is pressure drop or something. Okay. Got it? So whether you have it or not, you will write about the calculation part. You will do the calculation. And same thing is over here. Give the discussion of every topic learned in class. You must give discussion on the working principle of each item in this section, whether you use it or not. If you don't use it, state the reason. The content must include the discussion on blah 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 blah. Let's say you don't use line heater. I think none of those groups use line heater, right? Let's say you don't use line heater. You will give discussion about the line heater. You say, okay, in this project, line heater is not used. the discussion of line heater is given in here for the completeness of the project. Line heater is used mainly for preventing hydrate formation. The way it works is blah 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 blah. Okay, and you don't need to show any calculation example. Calculation example is over here. Line heater sizing. I know that you don't use line heater, but you say you don't use line heater. But line heater sizing is based on this. So you show hydrate chart. Assume that hydrate formation temperature is this much, and assume your specific capacity is blah 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 blah. You may take the homework or the exam, okay, question to show your calculation example, but it must not be identical. You have to change number and redo it or something, okay? The purpose of all this is to make sure that you know everything in this class and we can use it to replace the final exam. If something is already in your project, discuss as usual. But if it is not, you still show calculation example on this part. Right? There are 16 things to do calculation example. And we have heat transfer calculation, we will cover it today. You will give the calculation example. Okay, right now everyone is here, right? It's 1:06, but I don't consider you are late. You are on time. If you don't have quiz, raise your hand. How many? Raise your hand. 1, 2, 3, 4, 5, 6. Just 6, right? 3, 4, 5, 6. Come here. Come here. 1, 2, 3, 4, 5, 6. Please come and get it. Okay. Okay. All right. The new section is about self-grading section. Okay. You have to put this section before the effort distribution clarification section. Self-grading section. Each team member will need to give a score to all team members from a scale of 0 to 100, including himself or herself. Okay? When you grade yourself, use the grading criteria at the end of the comment. Okay? Grading criteria is this. Appearance formatting, that is quite subjective, right? Teamwork is somewhat quite subjective. Calculation example is not quite subjective. So let's say you didn't show one calculation example, the rest it is just fine. You get -10 from this part. Okay. Subject matter discussion, let's say you didn't show one discussion, you do -10. So let's say my team has 2 members. Okay. I am in charge number 1 to number 8 for for the calculation example. Number 1 to number 8. Okay. And for number 2 topic discussion, I'm in charge number 1 to number 12. Okay. And 12 to 24 is another team member. So everyone submit just one copy, okay, per team, one copy per team. But you may do more. I will talk about it. So let's say my team member do it just fine, but I get lazy, so I don't do like unit discussion. I don't do separator discussion. Okay. I don't want to do Hammer-Schmidt calculation because I don't have hydrate. Okay. I don't do Hammer-Schmidt calculation. So I missed totally 3, right? So in effort distribution, I have to say, okay, I am responsible for number 1 to number something, and another team member responsible for number 9 to number 16 or something. For the calculation example, for the discussion, another team member responsible for number 13 to number 24 or something. So in grading section, let's assume I give myself 100. My friend, very good friend of mine, give myself 100 and give himself 100 too. Okay. I also give him 100. He did everything, but I missed 3. So I missed 2 discussion and 1 calculation. So I missed totally 3. Okay. So when my team give me 100, I give him 100. I give myself 100. He give himself 100. But I missed 3. So miss 3 means 70. Okay. Miss 3 means 70. So both of us will get 70. Scenario 1. Scenario 2. I give myself 100. I also give my team 100 too. But my team say, hey, great, you should get just 70 because you didn't do the part that you should do. 1 to 8, you missed 1, and 1 to 12 of discussion, you missed 2. So you missed totally 3. We have good teamwork and the report looked very good, but you didn't do 3 of that. You should get 70 and I should get 100. So when I grade it and I check, hey, in the effort distribution classification section, it say a grade is responsible for number 1 to number 8 and number 1 to number 12 for the discussion part, but he didn't do 3 of them. So what I will do is I will give student 1 a grade 70 point and student 2 100 point. Okay? So if everything is perfect, everything looks very good, and you want to get the same score as your teammate, give everyone 100. Doesn't matter. Okay? But if you believe that your team didn't do it, except the team that discussed with me already, okay, there's one team, you know which team, right? All of you come to see me. So I don't have any negative point on your teamwork. And if you are just one person in this team, in your team, you get 10 points, free 10 points, because you have very good teamwork. You're just one of that. If your team has only one member who takes 4405, do half of section 2 and half of section 3. Section 2 and section 3 is calculation example and discussion thing. If you are only one, and it's only one group that have that condition. Okay? So unless you have talked to me before and you have complained about your team member before, if you ever give your team member less than 100, the teamwork may be, okay, let's say your team had 3 people, okay, and one person didn't work, so you get what? 2/3 multiplied by 10. Okay, so if 2 people didn't work, you get 1/3 multiplied by 10 on the homework, on the teamwork part. Okay, it's just not much. Okay, but if they really do something bad, then you don't get the score. So let's say 1 people, I have 2 members. 1 member missed 3 of that. I give him 70. Okay, so instead of 100, I get 95 because I don't have perfect teamwork. My teamwork is half of the team didn't work, so it's not quite teamwork. So I get 5 points. Okay, but the rest is perfect, so I get 95. Another person get 65 because he didn't do 30 points and he missed, like, he didn't have teamwork part. Your team doesn't have teamwork, so the teamwork score is the same everywhere. Another reason that is more than this. Okay, Rohan, we have quiz today. Do you want to take a quiz? Yes, please come. Yeah, come take it. But you write on it that you are here at 11:13, which is late. Okay, good.
Yeah, no problem.
No problem. You already have extra for him? Alright, another reason that you want to give your team member less than 100 is, for example, just the example, have no intention to talk about any previous case or anything. Okay, let's say we talk about compressor and your team copy and paste from Wikipedia and something about turbocharger in the car, which is completely irrelevant to this. Okay, and you say, hey, team member number 1 is responsible for point 1 to point 6, but didn't do anything on the calculation part. And I found that in that part, it's copy and paste from Wikipedia. didn't sign anything. Okay, he did that. So your team has what, 5 members, and 1 member didn't do anything, but you talked to me previously that he didn't work. But he should, please work. So, but he didn't work. I didn't minus any teamwork score on it because you complained it, right? Like very early. So I put here, I think there's a grade something. The grade of this report is not proportional to the number of words. Yet, for the report where the number of words is less than 3,000 words, 0 score is given automatically for the whole team. Okay? If it's too thin, less than 3,000 words, everyone just gets 0 to be easy for me. Okay? F for the whole course is given if you copy and paste from other source to the point where it can be considered as trying to claim other people's work as yours. If you cite, it's not the same as you try to claim other people's work as yours. Even though you copy 2 sentences, 3 sentences, or maybe even one paragraph from Wikipedia, okay? But you say, okay, it's from Wikipedia. I didn't write it by myself, but I should not rephrase or anything. So I grade as usual. But try to limit the word by word copy. Okay, you should rephrase, or you should make it match to your situation. Just cite. But if you can, don't try to copy word by word. If you just have copy word by word, and cite, and the whole report is more than 3,000, I don't think that's fair for me, you know. And I will find out who do that, and that particular person, I don't need to give you minus 5 to 10 for each low quality example, or minus 5 to 10 for each low quality discussion. If one section, let's say about line heater or about compressor, you just copy from Wikipedia, and I may just give you 2. Okay, you Google it, you see it, you didn't rephrase it. I don't have any evidence that kind of information go into your brain, so you get 2 out of 10. Doesn't need to be 5, right? If you do very bad, but typically it's minus 5 to 10. Okay? Yes, question.
Hypothetically speaking, for that group that has the thing, do they need to do that teamwork thing to grade all or no?
What?
For the group that you're saying that has that thing, they need to do the individual teamwork.
So the teamwork part. So let's say your team has 5 people and 1 people didn't work and you talked to me before. Okay? If that team member didn't work again, you get teamwork 10. But if that team member work, but another team member, which is in your team that you didn't complain against, didn't work, then you get 8 instead of 10. Okay? Okay? Just for today, anyone want to complain about that teammate, come to see me, okay? If you don't want to get lower teamwork part, but whenever you come to see me, I will have to notify your teammate too. Alright, so just graduate and don't try to fight each other, okay? For the exam, okay? Exam score is graded partially, and one student get 104 or something, another student get, yes?
I was raising my hand, that was me. I got
What? One student get, is that you? One student get 104 and another one get 100 something. You want me to clap my hand? Really? That's you, right? Well, I'll go and check if you really get 104. Okay.
Are there any negatives yet?
We come to 0. When we get to 0, you get less than that. Tomorrow, Arya will finish all the grading and give the grade to everyone. And we will discuss more on Thursday on what do we do, okay? I think you guys are being a good student and you come to class every time, right? Most of you. Otherwise, you write your report. So overall, it's kind of good. So I may have to consider something to. talk more on Thursday. Okay. And we'll talk about it on Thursday. So wait until the score come out. It may not be that much bad. Arya told me the average is maybe about 70 or something, or 68. So this means some people get, if we have people that get 100 and average is 70, this means some people also get 40. And that's some kind of concern. So I may have to consider, like, for the question that no one get it right, I may have to do something with it or something. So for some question that no one did it right except me, I think about it. We may just have you, I know that the end of the semester is coming up, but there are several options for doing that. I haven't decided yet. Option 1, don't do anything. That's option 1. Okay. Option 2, on the blackboard, I already upload the exam and exam solution, exam 2 that you did. Anyone have seen it? It is in exam, 2018 exam. So, exam 2018 solution. And the whole calculation is in the Excel sheet. I didn't make the complete solution, but it will give you some idea on what it is. The part that I cannot do anything is like the first part. I can be a little bit more generous, but that is on the calculation part. Like for example, this kind of thing, it's just -1, 0, or +1. Cannot do anything. Okay. And the solution is here. Try to check it. The reason that I uploaded this is maybe for some student who are about to get F or get D or something, I may just C is fine, at least for me. So I may ask them, okay, with the consent of the like 2/3 of the class, can we have that person write all this by himself and increase the score to 50 instead of 0 or something if he gets 0. But I may not do anything. I'll take a look at the score first because I don't think it's that bad, right? And that's the exam solution. Homework. We have the last homework uploaded. I didn't upload it last Thursday or last Friday or Monday. You need to take this class before you can do the homework. Okay. The homework is, I understand that it is very busy work, very busy week for you. The homework is, I will discuss about it now so that it help a little bit. So assignment 10. In this assignment, everything you can do it by Excel, okay? So first one is a two-phase flow question. I give you X, I give you Y value, and I ask you, what is VSL? What is VSG? What's the random number? Okay. To do all this, you need to know the formula. Okay. The formula is the formula for X and Y. It is in the lecture itself. Okay. So what happened is, I wonder if I know that it's annular flow, what is the corresponding standard activity foot per day or something, okay, for flow in the well. So if I have the annular flow, what happened? So what you have is X and Y, but you are asked to calculate VSL, VSG. This means you need to use cosec, okay? You may need to use cosec or you may use some other method. Once you put all the formula in there, so I think X is 0.1, Y is 10, and I say theta, that's my theta, flow upward vertically. So theta is pi/2, okay? Angle of theta is pi/2. So I have 0.1, X equal to 0.1, X, that is 1, 0.1 is over there, and Y is equal to 10. So my point is about that point. Okay. My point is about that point. So that is the operating point. I would like to know what is VSL and VSG to make that happen. Okay. Based on VSL, VSG, you can calculate the flow rate, right? But it's kind of somewhat implicit because when you know angle, sin theta equal to 1, you know G value 9.8, right? Fluid property is given. So you can directly calculate this based on the Y value minus dPdL, which is this term in the bottom, okay? But this term in the bottom, you have VSG over there and VSG over there. So you may have to change VSG until your bottom part equal to what it should be. Okay? So you may have to use cosec, or you may do analytical solution. I think analytical solution is also exists, but you can also do cosec. So first, y is equal to 10. Put 10 over there. You can do it, right? You know density of each. Substitute the value over there. You know g value. Substitute it over there. You know sin theta. Substitute it over there. Then you can calculate the numerical value of minus dPdL. Good. So your test is, and minus dPdL is defined as this. Okay. So your test is use method 1, analytical method. Method 2, cosec, change VSG until minus dPdL match to the value that you get when you calculate based on y. Once you get minus dPdL sub SG, so you get bottom part of this one, right? When you get the bottom part of this one, based on y value, you can adjust VSL until, but you have to take the square root, okay? Adjust VSL until x become 0.1. Good. So it's just use cosec, very easy. Okay. I don't quite worry much about that. How long does it take to do that? Put the formula in, do it, double check it. Less than half an hour. Should be half an hour easily. Okay. Another one is using the Excel template. Question 2. For the flow of oil in a subsea pipeline, use a given Excel template to calculate the pressure drop and the temperature profile. Okay. This is a given information. It looks like it's a lot, but basically, you will open this file, Excel template, already uploaded. And for example, you have to change from 1,000 Q to be 60,000. So you use the existing template, but you do some adjustment. Okay? And you do the calculation of temperature profile for the case of insulated pipe. This one is insulated pipe but not buried. Okay, we insulated but we didn't bury. And you should be able to give me the graph. Select the right graph. Okay, but you have to do some adjustment first. And notice that this time we do it just for mine. But the question over here is temperature profile over 50 mile, not 4 mile, 50 mile. Subsea pipeline can be very long, like 50 mile. Okay, so I asked you to do 50 mile, not 5 mile. So you just have to change the number over here. Maybe you add, you see this L20, you start from 0, that's okay. But instead of plus 100, you plus 3,000 meter. So every step you jump like, or maybe, so I change from 3,000 to be 1,250. So, and then I double click on the corner. See, I click this one, I change the formula inside to be plus 1,250 and I double click on the corner. So everything changed. So now my profile will be up to about 50 miles. Okay? Good? We'll talk more about this on how we do it, okay, in this lecture. Are you ready? Yes? Okay, last time we talked about the formula, and you already write out the formula. So, okay, I know that this equation for temperature profile estimation is just given without derivation. Okay, just have to trust me that it's correct. It is derived based on the assumption that we reach steady state for velocity profile. Velocity doesn't change with time. That's the assumption. Assumption number 2 to derive this equation is that the temperature profile reach the equilibrium quickly. Okay, temperature profile reach the equilibrium quickly. Why do I say that? Think about this. If your pipe can store a lot of heat, okay, if your pipe can store a lot of heat, even though inside the pipe is hot, fluid inside the pipe is hot, okay, so fluid inside the pipe is 140 Fahrenheit. 140 Fahrenheit. Initially, the pipe is at 60 Fahrenheit. It may take a long time for this 60 Fahrenheit to reach like 140 Fahrenheit. Okay? Because the pipe itself can store some heat, right? But I don't consider that transient. I say the temperature profile, the heat transfer reach equilibrium. So this means inside feel whatever happened outside instantaneously. Okay? Which is not completely true. It takes about, could be 1 minute or 30 seconds. But if you think about the heat transfer calculation in subsea pipeline, most of the time it's used for wet deposition calculation. And wet deposition take like week or month to have the deposit. So this much is fine. So we have the equation, okay, to have temperature profile at any location. Let me explain a little bit. Temperature at any location, this one is what we want to find. Okay? T infinity is the environment temperature. Environment temperature. Okay? Inlet temperature, this is temperature at inlet. Okay? We have a long pipe, 50-mile pipe. Temperature at the inlet is that T inlet. Okay? T infinity is environment temperature. Like subsea temperature is about 5 Celsius or 40 Fahrenheit. Okay? Subsea, it doesn't mean like minus 10 Celsius or something. At subsea condition, water stays as water. It's not like ice or anything. Okay? So U, that is overall convective heat transfer coefficient. Capital D is the diameter that U value is referenced at. So if U value is referenced at the inner pipe diameter, that D is the inner diameter. M dot is the mass per time, mass flow rate. In situ mass flow rate, okay, kilogram per second. Cp is the specific heat capacity of the fluid inside. Okay. Think about this. This say we have some kind of temperature drop. Temperature decay exponentially, okay, because it is e to the power of minus some constant. Okay. So you see that exponential decay. And look at this equation again. I ask myself, hey, this top part, other than z is the length from the inlet. So that coefficient, it is constant. Most of the time it's constant, okay? If it is not constant, you have a long pipeline, then you have to break it. chop it, okay, discretize it, and then you calculate the temperature profile in each small section. But for the time being, we can assume easily that it's constant, okay. So this means when the length is small, temperature drop more exponentially. What will make it drop less? What do you think? So if the constant over there is big value, a little bit of z will make the temperature drop a lot, right? So this means I have small m dot, okay? M dot is mass flow rate. I flow slow, very slow. I flow very slow. So this means the temperature drop, the temperature change with distance is quick, right? Small denominator make the whole term bigger. Make sense? Or if we have big U value, big U value means a lot of heat loss. Okay, big U value means a lot of heat loss. If I have a lot of heat loss, temperature will drop quick. Okay, temperature will drop quick. So that's next thing is, hey, great. If I have fluid flow faster, I have less temperature drop, but do I have less heat loss? I will have to ask you, what is the unit? If you say heat loss in the unit of like BTU or Joule, flow faster typically have more heat loss. Okay, flow faster have more heat loss, but it have less temperature drop. Think about this. If I flow 100 kilogram per second, that's extremely fast. Typically, you are in the range of 1 kilogram per second for a big subsea pipeline. So if I flow 100 kilogram per second, I have the temperature drop just 0.1 Celsius, okay, temperature drop of 0.1 Celsius. In another case, I have just 1 kilogram per second, but temperature drop is 1 Celsius. 1 kilogram, temperature drop of 1 Celsius, you know, heat loss you may roughly estimate as mCp delta T, right, or m dot Cp delta T. So delta T, which is 1, multiplied by m dot, which is 1. So heat loss is kind of in the order of magnitude of about 1. But that one, when you flow faster, even though the temperature drop may be slightly smaller, 10 times smaller, but the multiplication is still more. So when you flow faster, even though there are less temperature drop, but it could be more heat loss. And the reason of that has to do with U value. Okay, U value. We will go with that in a minute. But when we flow faster, even though we have less temperature drop, it doesn't mean that we have less heat loss too. Temperature and heat loss is related, but may not be one-to-one. Okay, here's a formula that you write last time to calculate the U value. Overall heat transfer coefficient basically is telling us about what is the heat loss overall. Okay, so if U value is high, this means it's easy to lose the heat. If U value is low, this means it's difficult to lose the heat. Okay, it's a combination of several things. So let's say HI is convective heat transfer coefficient of the fluid in the pipe. HO is convective heat transfer coefficient outside the pipe. So we have fluid flow in the pipe, okay, and heat has to go to the wall, and from the wall through the pipe thickness, and from the pipe go to the environment, right? 3 steps. When it go from inside the pipe to the wall, that is convective heat transfer because the medium is moving, right? Inside the pipe is conduction. Outside the pipe is another convective heat transfer. Good. So outside the pipe, what make us have a heat loss outside the pipe? We have heat loss outside the pipe because the environment. Either we have the wind blow over the pipe, or we have sea current moving around the pipe. So subsea still have some water moving, right? Flow over the pipe, around the pipe. So if this value is very high, this term just vanish. But it doesn't make anything error in your program, okay? It's just gone. If I put insulator is sometimes they make it out of some kind of polymer or something, or polyurethane. I put polyurethane on it. Last time we put the value of polyurethane K value, right, 0.02 something. It's very low. So this make this term to be very high. And then if you make this term to be U value to be very low. So this means the overall heat transfer coefficient is not quite sensitive to the high value of heat transfer, but it's sensitive to the low value of heat transfer. So if we have copper, if pipe made of copper, R2 minus R1 something divided by K of copper. K of copper. So copper conduct the heat very good. So this term is kind of very low or vanished. But whenever we put something that can resist the heat very good, this make some good change in your overall heat transfer coefficient. What about HI? How much is the value of HI? If it is laminar flow, fully developed, it could be 3.6 or 4.2 depending on the boundary condition. If it is turbulent flow, that's a Nusselt number, that's not the H value. So H value can be low for laminar flow. For turbulent flow, H value can be high. We'll talk about that in a minute, but all this you know how to substitute the value, right? If HI value is given, HO value is given, then we can calculate the U value. From the U value, we put it back into that equation. Everything else is known. We can plot temperature at any location. Question? No question? You have to do this, okay? It is in the Excel file. How do I do that? In Excel file that is given to you already, I have one cell called exponent without z. So I have minus 2 something, okay? That's the exponent without z. So that exponent is this term, okay? That exponent is this term. So I just use, once I find the exponent, I know T infinity or 40 Fahrenheit. Then I go back here, then I can tell temperature of the fluid. At the beginning I put it as 150, no problem, right? 150, no problem. Next cell, you see the formula M20 minus 35. 35 is, in this case, is T infinity. So you should change to 40, right? Because your case is T40. Multiplied by exponential of G54. G54 is the exponent. And L21 is this length in meter, length from the inlet. And plus 35. Plus 35 is come from this part. The formula that we have, I just multiply the whole bottom thing on this part and I add with T infinity. So for your case, in the homework, T infinity or environment temperature is 40 Fahrenheit. So you have to do 40. Okay? The unit on this side has to be matched. What if you use Fahrenheit for everything. If you use Celsius, use Celsius for everything. The unit on this part have to be SI. SI only, because your CP value, typically you get it in SI. Sometimes you may have in BTU or something, but okay. So if H is given, you can be calculated and then you can plot the temperature profile, right? Questions?
Question? No question?